Okay, so next is an inverse normal distribution. So effectively all this means is what is the value when you are given a particular probability or area? Like the binomial calculations, it only understands the instruction for less than, which is why it's, again, really, really important that we're doing sketches for these ones. So let's say a variable x is normally distributed with a mean of 25 and a standard deviation of 3 squared. So let's find the value of a to 2 decimal places given that the probability that x is smaller than a value a is 0.75. So, as all the others, we're going to sketch and we're going to put our mean. So if we want the probability that something is less than a value is 0.75, that's going to mean that our value here, our value for a rather, is on that side because it's more than half. So it's going to have to be on the right-hand side for being less than something is more than half. This, I think, is much easier, actually, than the first one. So we're going to get our calculators, like we did before. And we're going to go to distribution, like we did. This time we're going to go to number 3, inverse normal. So the area, excuse me, is the probability. So 0.75 is the probability, the standard deviation is 3, and the mean is 25. So the value to 2 decimal places is 27.02 is our value of a. Okay, so we want to know what the value of a is when the probability that x is greater than a is 0.4. So the probability that it's greater than a is less than half, so it must be on this side, and this is 0.4. Now my calculator can only work when it knows this information. So if the probability of it being greater than a is 0.4, then the probability of it being less than a must be equal to 0.6. And this is what I'm going to use to put in my calculator. So the same thing as before, go to distribution, inverse normal 3. This time the area I'm putting in 0.6. It remembers everything else at the moment. So 25.76 to 2 decimal places. Okay. Part C, find the probability that a value taken between 20 and a is 0.3. So 20 is there. A, excuse me, well, 0.3 I think is probably just below 25. It might be just over 25. Because this is just over a standard deviation away. So 30%, we know up to 1 standard deviation away, 23 would be 0.34 of the probability, so that's probably about right. So we want that information. And I know that that is 0.3. So I now have multiple bits of information that I don't know. So I don't know what's less than a, which is what I need to put in my calculator to work out what a is. What I can work out on my calculator is the probability of being less than 20. Because the probability of being less than a will be the sum of 0.3 and the probability of it being less than 20. So I'm going to put this in my calculator. And this is using my normal calculation, so my normal CD. So my lower bound, -1 times 10 to the power of 99. My upper bound is 20. My standard deviation, now what you'll find interesting is even though I haven't done anything in this section, it's taken over the standard deviation and mean from my inverse normal. So my calculator knows that I'm working through this question, so that's really helpful. So the probability of being less than 20 is 0.04779. So I'll do 4 significant figures. So therefore the probability that x is less than a is going to be equal to 0.34779. So now I'm putting in all of that into my calculator, my inverse normal function. So my area, so you can see I am actually typing it in, even though you can't see it on the screen, 34779. Standard deviation, etc. is already there. So therefore A is 23.83 to 2 decimal places. Okay. Part D. I want the probability that x is between 25 minus a and 25 plus a, and that is equal to 0.8. So I need the value of a given this information. Now what's helpful is that it's talking about things that are either side of 25. Well, 25 is our mean. So I've got a value here which is 25 minus a, and a value here which is 25 plus a. And I know that the probability of all this in the middle is 0.8. So at the moment that's not very helpful. But if I know that all of this is 0.8, then I know that this bit and this bit added together must be 0.2 because it's symmetrical about the mean. So 25 minus a number and 25 plus a number, it's symmetrical around the mean. So this value must be 0.1 because that would be 0.1 and this would also be 0.1. But how I can use this is that I can say the probability that x is less than 25 minus a is 0.1. And I can use that to work out what 25 minus a is. So my area is 0.1, 21.16. Oh, use a different colour, well. 25 subtract a is 21.16 to 3 significant figures. So therefore a, which must be 25 subtract 21.16, is 3.84. So this is one of the examples where actually understanding our symmetry is really, really important. Generally with these kind of questions you will be given either specifically what the mean is, or it might even put mu for a question like this. So we're now just going to look at a question in context so that we can apply our question. So plates made using a particular manufacturing process have a diameter which can be modelled using a normal distribution where D is normally distributed with a mean of 20 and a standard deviation of 1.5 squared. Given that 60% of the plates are less than a value of x, find x. So 60% are less than a value x. Always sketching. to really make it clear to you and to the examiner that you know what it is you're working out. So just using my inverse normal. So inverse normal, my area is 0.6, my standard deviation is 1.5, and my mean is 20. So x is 20.4 centimetres to 3 significant figures. Part B. Find the interquartile range. Well, interquartile range, we're now going all the way back to GCSE, although it is in Year 1 stats as well as a brief reminder, but upper quartile take away lower quartile. So that means we need the 25th percentile and the 75th percentile. So I need to work out my value that's in the upper quartile. That would have a probability of 0.75. And my lower quartile, which would have a probability of 0.25. So my upper quartile, area 0.75, 21 point, and I'm going to put again a few decimal places just to make sure, 21.0117, I think that'll be enough. And then I'm going to do my lower quartile with 0.25, which is 18.9882. 6 ... Because this is the last one I typed in, I can use all of the digits and it won't be as difficult to do. So I now want the difference between them. So the interquartile range is 2.02 to 3 significant figures. As long as you know how to use your calculator for something like normal distribution, the vast majority of these questions are really straightforward.